Hello, welcome to this video. Today we are not going to calculate this integral. This integral actually was from the MIT Integration Bee, the year 2020. We're not going to calculate it. We're going to calculate a more generalized version of it. So, not looking at 2020, not a 2n, just a natural number n. Actually, before we calculate this integral, there are two things we need to do before getting at it. Two things we need to establish. First thing we have to look at is this. When we have something like an, a function of n, is equal to b when n is even, or c when n is odd. This is the most generalized you can have. So what I'm going to do is replace b and c with 1 and negative 1, which is the most basic case. So an is equal to 1 when n is even and negative 1 when n is odd. And the base for all of this is, when in this specific case you have 1 when n is even, negative when n is odd, it's negative 1 to the n. When n is even, negative 1 to an even power is 1. When n is odd, negative 1 to an odd power is negative 1. That's where everything comes from. And let's do a quick example to see how this works with other numbers. So let's take, for example, 7 when n is odd, and 7 when n is even, and 3 when n is odd. So, well, what we are going to do is, you can say maybe subtract 5 from both of these and add 5. Because in both cases, you will add 5 to our subtracting 5 of this, or subtracting 5 of this. And is even or odd, doesn't matter. We can say we can take a 5 out. And it's going to be 2 when n is even, and negative 2 when n is odd. Again, just want to clarify. When n is even, it's going to be 5 plus 2, 7. When n is odd, it's going to be 5 minus 2, 3. Doesn't change anything. Now, we're going to do a similar thing, but with multiplication. We're going to take a 2 out of these. So it's going to be 5 plus 2 times 1 when n is even, and negative 1 when n is odd. And now we know what this is. This is the basic case where everything comes from, negative 1 to the n. So, in the end, this is going to turn out as 5 plus 2 times negative 1 to the n. That was just a quick example. Now let's look at a general case, not the most generalized case, where it's something b when n is even, but 0 when n is odd. That's all. Alright, now we have this case. Similarly to previously with 7 and 3, we want something here and negative something here. So we can then use the negative 1 to the n times what we have. And it's easy to see that what we will take out is b over 2. Because then we'll have remaining b over 2 when n is even, and negative b over 2 when n is odd. And now, again, take out a b over 2. Then we're going to have a b over 2 plus b over 2 times, we have 1 when n is even and negative 1 when n is odd. And now again, the base case, this is negative 1 to the n. So we're going to have b over 2 plus b over 2 times negative 1 to the n. So, and that's our formula. When n is even, it's b. When n is odd, is 0. We'll have that sort of thing going on. It's just equal this. Let me write this bigger. B over 2 plus b over 2 times negative 1 to the n. Alright, that was the first thing we need to establish. Now let's go on to the second thing. Second thing we want to see is the integral from 0 to 2 pi of e to the I x times n dx. What is this going to equal to? Well, this is actually going to have to break down into two cases. So, one, when n is not equal to 0, and the other one when n is equal to 0. So let's see. When n is not equal to 0, we're going to have to, and since we have e to the x times something, it's going to be the antiderivative e to the x times the thing, that same function, divided by y to multiply by x. So it's going to be, so the actually not the integral, so it's going to be e to the I times x times n over I times n. Again, because n is different than 0, we can divide by n and we'll have no issues. And it's going from 0 to 2 pi. Now I will take out a 1 over I times n out of this, and we'll see what we have. We'll have e to the 2 pi n times I minus e to the 0 times n times I. Now, n is an integer, natural number, but now when we have e to the 2 pi I times some integers, which is what we have here, it's always going to be 1. You can easily see that if you use Euler's formula, which we derived in one of my first videos. Meaning that this is 1, and this is going to be e to the 0, which is 1. 1 minus 1 is 0. All in all, this is going to be 0. Now, for the case of n is equal to 0, we can't divide by n, because that's going to cause us a bunch of issues. And so we're just going to plug into here n is equal to 0. We'll get the integral from 0 to 2 pi of e to the I x times 0 dx, which is going to be the integral from 0 to 2 pi. Now let's see. 0 times I times something is going to be 0. Anything to the 0th power, except 0 of course, is 1. So we'll have the integral of 1 dx. But then that's easy. The integral from a to b of 1 dx is just going to be the difference between the upper bound and the lower bound. So it's going to be 2 pi minus 0, which is 2 pi. So, to summarize, this is equal to 0 when n is different than 0, and to 2 pi when n is equal to 0. That was our second establishment. Now let's go on to actually finding the integral, the goal. Alright, now that we've established these two formulas, we're going to go on with the integral. First thing I want to do is use the complex definition of the cosine x, which is cosine x is equal to e to the ix plus e to the negative ix over 2. I'm going to turn this over 2 into a 2 to the negative 1. So 2 to the negative 1 times e to the ix minus plus e to the negative ix. So we're going to plug this in here and see what we get. So the integral from 0 to 2 pi of, now 2 to the we can break this apart into 2 to the negative 1 to the n times this to the n. So it's going to be 2 to the negative n times, we'll have e to the ix plus e to the negative ix to the n dx. Alright, now what we're going to do is use the formula of the sum of a binomial like this. So a plus b to the n. Formula that we've established in the past. It's going to be, I'm going to take the 2 to the negative n out because it doesn't play a role in the integral. It's just times this sum to the n. So 2 to the negative n times the integral from 0 to 2 pi. Now we're going to have the sum as k goes from 0 to n of n choose k. Alright, n choose k times this to the n times this to the times this to the k times this to the n minus k. So e to the I times x times k times e to the negative I times x times n minus k. And then this whole sum dx. The sum is still in the integral. Alright, now we're going to do two things at the same time. Switch the order of summation and integration and combine these two. E to the something times e to the something, sum the powers. Combine them. So we'll get 2 to the negative n, and it's going to be 2 to the negative n times the sum as k goes from 0 to n of the integral from 0 to 2 pi of n choose k times, now here we're going to take the negative put it into the n minus k. So this n minus k turns into a k minus n. And now when we add the powers, we can take I times x out in the parentheses. We'll have left k plus k minus n. So e to the ix times 2k minus n. Now, let's see, by this establishment, every time 2k minus n is not equal to 0, the entire integral times n choose k doesn't matter, it's just some number we're multiplying it by. So every time 2k minus n is different than 0, this entire thing is going to be 0. And notice that because k is an integer, because of the sum, it's a sum variable, if n is odd, 2k is even, so 2k minus n can never be 0. So we have one of two cases already. When when n is odd, this entire thing can never be 0, meaning that by this establishment, the entire integral is going to be 0. Summing how much of zeros is 0. So when n is odd, this is going to be 0. But what happens when n is even? Well, when n is even, there is only one k where this is going to be 0. K equals n over 2. For the rest of the k's in the sum, this is still going to be 0. And by this establishment, they're all going to cancel out because they're just 0. So what we'll have left is just where k is equal to n over 2. And the sum disappears. We're not summing anything anymore. So I'll have 2 to the negative n times, and now we have the integral from 0 to 2 pi of n choose n over 2 times e to the I times x times 2k minus n is 0. Again, by this establishment, the integral is going to be this choose and choose n over 2 times 2 pi. And then we have this times 2 to the negative n. So dx, this is going to be just when n is odd, this is going to be 0, but when n is even, it's not going to be 0. It's going to be 2 to the negative n times 2 pi times n choose n over 2. And now let's make it a bit nicer by taking this 2 into the power. So this 2 disappears, and this becomes a 2 to the negative n plus 1. Now we will use this establishment. It's something when n is even, but it's 0 when n is odd. So what we will get is just this over 2 plus this over 2 times negative 1 to the n. This over 2 will cancel out the plus 1 in the power here. So I'll have 2 to the negative n times pi, right? 2 to the negative n times pi times n choose n over 2. And then we'll have plus this times negative 1 to the n. The negative 1 to the n can also equal negative 1 to the negative n. So we can combine it into the power of 2 to the negative n, and we'll get negative 2 to the negative n. plus negative 2 to negative n times pi times n, choose n over 2. And that's it, that's the final answer. And before I end the video, if we're worried about when n is odd, even though it should be 0, we'll have n choose n over 2. When n is odd, n over 2 is not an integer. And by the way, if you're worried when n is odd, because we'll have something odd, choose something that's not even an integer, don't worry about it. It's all going to cancel out, because this is going to be negative and this all gets 0, just like we need to. So now let's end the video. Alright, that is it. If you liked this video, please subscribe to my channel. I'll be uploading more content like this in the future. And before I end this video, this quickly gives us the solution of the original problem when n was 2020. Just 2 to the negative 2019 times pi times 2020, choose 1010. So if you want to know what was the answer, that's the answer. Alright, goodbye.